Just like when we did linear stuff, we learned 3 different formulas. We learned slope-intercept, point slope, and standard form. Parabolas, there are 2 forms. Standard form was what we've been working with, but there's also something called vertex form. And it's called vertex form because the vertex is in that form. So you're able to quickly identify it without having to do negative b over 2a. But it says each function in the first column is written in standard form. The second column, each function has been rewritten in vertex form. Complete the values for negative b over 2a and for h in each row. So for the first one, if we're plugging into negative b over 2a, this would be the opposite of b, which would be positive 4, over 2a. A is 1. So 4 divided by 2 is 2. Now notice in vertex form, it's a times the quantity x minus h squared plus k. So the formula has a subtraction sign in it. So whenever you're identifying what h is, it's actually, if you want to think of it, it's the opposite of what you see. So if you see a negative 2, it's a positive 2. But the formula is x minus h, so h is just 2. So you can notice that the vertex, the x-coordinate of the vertex, is actually showing up in vertex form right there. If we were to do the next one, we would do negative b, which would be positive 12, over 2 times negative 3, which would get us 12 over negative 6, which will get me negative 2. And the second one, vertex form, again, we're looking at what h is. Now h looks like it's 2, but the formula is supposed to be x minus h. So this is really x minus a negative 2 squared plus 4. So the value here would be negative 2. And you can see that those match up. So when you're looking at vertex form, again, a lot of students like to think that the h value is the opposite of what you see. So if you see a minus 2, the h value is a positive 2. If you see a positive 2, the h value is a negative 2. So if you want to memorize it that way, or you just have to remember the formula has to have a subtraction. So if it has a positive, that's really minus a negative, showing you it's negative. All right, so in our notes, let's jot down again what standard and vertex form are in these little blanks. So standard form is right up there. Y equals ax squared plus bx plus c. And that's how we've been graphing them thus far. We found the vertex, which was our negative b over 2a, comma, blank. And the axis of symmetry was x equals negative b over 2a. And we also used our graphing calculator in the past to help us with get our table of values. Now, vertex form, as you can see up here, is written differently. Y equals a times x minus h squared plus k. It's called vertex form because the vertex is in this form. The vertex is h, comma, k. Which makes the axis of symmetry x equals h. Now, vertex form is useful just like when we did absolute values and we would see like plus 2, we knew that was shifted up 2 or down 2, and then inside if it was adding, that was left or right. The same thing happens in vertex form. We're able to identify the shifting of the parabola without having to necessarily do the table of values. So all of the translations are listed here. So you can see if you have plus k at the end, that's going to go up k units, just like the absolute value graph did. If it has a minus k, you're shifting it down that many units. The horizontal translations, which you'll remember, if you see plus inside, that's when you go to the left. So you take your parabola and shift it left. These were the ones that a lot of you like to remember were the opposite of what you think, because normally positive would go to the right, but it goes to the left. And the minus goes to the right. We've already talked about this one. If you see a negative, that means that the parabola does need to be reflected across the x-axis downward. And we talked about these too when we did absolute values. The a value is going to be a stretch. And if a is between 0 and 1, meaning it's like a fraction, that's when it's a shrink. Okay? So these kind of act almost like slope, but they will. You just want to remember that they do modify your values. So you might want to do a table of values if you have an a value that's not 1. All right. Really quickly, on this graph, let's graph the parent function too, just so you guys can see what the parent function looks like. And then once, if you want, you can memorize the first few terms, like how much you count up and over, and then you wouldn't have to do a table of values every time. So the parent function for y equals x squared, let's just do 0, 1, 2, 3. So 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So the parent function would start at 0, 0. It would go up 1 over 1 to get to 1, 1. Then to get to 2, 4, you would go up 3 and over 1. And then to get to the next point, that's 1, 2, 3. So it goes up 1 over 1, up 3 over 1, and then it goes up 1, 2, 3, 4, 5, and over 1. So if you want to memorize that, you don't have to do the table of values every time, as long as the a value is just a 1. So it goes up 1 over 1, up 3 over 1, and up 5 over 1. And that's the parent function. Now we're going to shift that up and down, but once you have your vertex, then you could just follow this pattern, and you wouldn't have to do a table of values every time. Now that's half of my parabola, so remember we would also have to reflect those points across the axis of symmetry, which happens to be x equals 0. And then just drop down up at the top that that's just the parent function. That's not my actual answer. And you won't have to do this for every single one, but again, just observing the pattern. Some of you will like to memorize this part so that you don't have to plug values in every time. Okay. So this one is in vertex form, so we want to identify the vertex. So you may want to jot down the formula, either above or below it, until you feel comfortable. And the way some of you will make the mistake of just doing the sign wrong in terms of the vertex. But again, since this is x and this is a minus, h is really 3. If you want, just remember it's the opposite of what you see. So since I see a minus 3, it's going to be a positive 3. And then my k value is 2. So my vertex is 3, 2. No work required, just looking. The axis of symmetry then is x equals 3. So when I'm graphing this, I'm going to go 3, 2, put my vertex. If you want, you could also draw in your axis of symmetry. Awesome, can you see? Now, if you don't memorize this pattern, then you're going to have to plug in a couple numbers. So maybe plug in 4 and 5 and then do your order of operations. But if you memorize the pattern that we have here, all you're going to do from this point is go up 1 over 1, up 3 over 1, and up 5, which is going to go off the graph, and over 1. And then we'll reflect those points across the axis of symmetry. And we'll graph it. So if you memorize the pattern, you don't have to do as much work. Now, could we also use our graphing calculator to get the table of values? Yes. So you can type this in your graphing calculator just like we have been doing in the past. You just type it in exactly like you see it. So we would press our y equals button, clear out anything we have. You'll type it in exactly as it's written with parentheses. And then plus 2. So x minus 3 quantity squared plus 2. Again, you could press graph and see the picture of it if you want. You could still find the vertex how we did before, but it's kind of a waste of time when the numbers are right in front of you. But you could also use the table of values to find some of the other points that we want to plot. Okay. Now, I will warn you, when you get to pre-calc, there are some units that Mr. Crowley does without a calculator, so that's why I like to show you both ways. You also need to know how to use the calculator, so when you get to calculus and physics, that you know how to use it. So it's kind of like a double-edged sword. You want to know how to do both. So try not to rely only on one of the methods. try to do both when you're doing your homework and stuff. Okay, let's flip to the back. We're only going to graph the actual functions here. We're not going to graph the parent functions as well. And you know what? I didn't answer the first question correctly. I'll do it on the back, but it had said describe, and I did not describe. So I would have lost points for not reading it. So when it says describe, you're just going to say left, right, up, or down, just based on looking. So looking at this, what would be our shift in our translations based on we're describing the translation? What does the 2 tell me, and what does the -3 tell me? Ashley? Good. The main reason I like you to list that is so that when you find your vertex, you make sure that that is actually the way you're moving it, left and down. Okay. So the vertex, again, this is x minus h squared plus k. So again, it's the opposite of what you see. So this should be a -2, comma, -3. Now make sure that makes sense. Left 2 and down 3. Makes sense, right? Matches up with the vertex. And then our axis of symmetry is just x equals -2. And then whether you want to punch that in your graphing calculator and come up with a little table of values. Do you guys have table of values on your notes? A little table, or no? Must be one of my old note sheets. If you wanted to, you could create a table of values. So if you don't like the pattern, then you would just pick a couple numbers, plug them in, or use your calculator. Or we can go back and use the pattern that we found on the front, which was up 1 over 1, up 3 over 1, and up 5 over 1. Now, if we have a stretch, an A value, a stretch or a shrink, you won't be able to use the pattern, okay, because it's going to affect each of the Y values. But in this case, we can see that A is 1. So the next one, we can see that it does have a negative. So that does tell me that it's been reflected across the x-axis. So whenever we do this, instead of going up 1 over 1, up 3 over 1, we're going to go down 1 over 1, down 3 over 1. This 4 tells me that I'm going to the left 4, and this -1 tells me that I'm shifting this graph down 1. What would my vertex be? Abby? -4, -1. Axis of symmetry, -4. Now again, A is 1. A is really a -1 if you wanted to think of it, but A is really just the number in front, not the positive or negative. So we can still do our pattern, but again, we're going to flip it downward. So I'm going to go down 1 over 1, down 3 over 1, and down 5 and over 1. And then reflect those points across. Now, the last two that we're going to do, you'll notice that these do have A values, which means we can't use the pattern. The pattern is going to be modified in terms of being stretched or being shrunk, so kind of like flattened out almost. So anytime you see that the A is not 1, you want to use a table of values after you get your vertex. The vertex you still find just normally, but coming up with your additional points, you will want to use a table. Use the graphing calculator or do it by hand, doesn't matter. So the negative, even though this is -1/2, the negative again is telling me that this is a reflection. The 1/2 tells me that it's a shrink, okay, which means the graph is actually going to be like flatter. The 2 tells me it's going to the right 2, and the 3 tells me that it's going up 3. So for this one, our vertex would be the opposite of -2, which is +2, comma 3. Axis of symmetry, x equals 2. But again, we want to do a table of values to pick some values that are bigger than 2 in the x. So maybe pick, and you could pick 1 and 0 and then reflect those the other way, or you could pick, which 0 would probably be, actually 0 would make it harder. Let's do 3 and 4. Which again, sometimes they won't fit on the graph, but now if you're doing this by hand, just to show you one by hand, we would plug this in. So we need to do some work. We'll have -1/2 times 3 minus 2 squared plus 3. Follow your order of operations. Parentheses first. Exponents next. 1 squared is 1. So that would just be -1/2 plus 3, which will get me 2.5. Do the same process, plugging in 4. For x. So 4 minus 2 is 2. 2 squared is 4, so -1/2 times 4. 4 divided by 2 is -2, and then add 3 to that, we'll get 1. Do the same process with 5, and so on, and get your other points. Now, you might want to pick 6 instead of 5. Why am I saying that? Well, 5 minus 2 is going to give me 3. 3 squared is going to give me 9. I'm going to get 9/2. So if you wanted to, you could pick something that's going to be divisible by 2. So if you do 6 minus 2, you'll get 4. 4 squared is 16. 16 divided by 2 will give you 8. So if you want, you can pick any numbers you want if you don't want to have to deal with fractions. Which is what I picked on here. I picked 6 instead of 5. And that got me -5, but it doesn't matter. You can pick 5. You'll just get a decimal. And then, of course, we'll plot those points. And reflect them. See if you guys can try the last one on your own. Again, because this a value is not 1, we want to do a table of values. And if you want to try it by hand, or if you want to do it in your graphing calculator, that's up to you. Our graph should look something like that. Axis, vertex, -1, -4, axis of symmetry, x equals -1. And then I just found a couple additional points. Again, sometimes when you pick another point, it might go off the graph because you're making it larger, and then that happens. You'll just do your best.